Hi, everyone. Hi, Patricia. Hi, Dylan. Free Fire Boss, Cristiano, Makisha, D'Angelo. Let's just jump right into it one time. Those sticks. So state the value of the underlying digit in the number below. Please tell me that value and what percentage of the shape below is unshaded. So what you need to look out for in SEA is that you read the question properly, because there are going to be some kind of reverse questions in this. So the first thing you would watch number 2 and think about is what percentage of the shape below is shaded, right? But they're actually interested in the unshaded region. You're lucky. We are fortunate that both of them have the same number. There are 8 parts, and 1, 2, 3, 4 of the 8 is shaded and 4 of the 8 is unshaded. So there is 4 eighths, which is equal to a half, and as a half as a percent is 50%. Anybody give me any number? Yes, that number is indeed 30,000. Once again, I need you to be very careful in these questions. If this is state the value, you put 30,000. If this said state the place value, the place value of the underlying digit below is only tens of thousands. Tens of thousands. Right? There's a difference. So if they want you to give the place value of a number, you give the place value. If they want you to give the value, you actually multiply the number by its place value. What number must be placed? So this is the algorithm question. What number must be placed in the box to give the results shown below? So if you have an algorithm question like this, you want to go in reverse. Put the car in reverse and go backwards, right? Because very likely they will want the starting number and they give you the ending number. So you need to go in reverse. Another thing they may do is give you the starting number and maybe leave out an operation. And yes, you will still want to go in reverse and then see what operation would be needed to you would need there to get the original number. Or you may go this way and try to negotiate what operation. Those aren't as hard. But this one, you just want to go in reverse, right? So the first thing you want to do is multiply by 11, and next thing you want to do is subtract 2. So 5 multiplied by 11 is 55. Subtract 2 is 53. And let's double check. If we place 53, wait. Yeah, if we place 53 inside there and add 2, we get 55. Divide by 11, we get 5. Understand? Go in reverse for these questions. So if you understand that, press the like button and share this with somebody. Call your neighbor, call your friend. Tell them we're getting things done here. We're revising. Press the like button. You all tell me how much likes you have on the video so far. Write the numeral that represents 411,306. 411,000. So in the thousands. So 411,000 and then 306. So the last 3 zeros, 306. I think Pat was the first one to jump out with that. Big up yourself. Big up yourself. So 411,306. Love and blessings. Wow, we are number 5 already. We gone in Italy. Right? 19 over 3 as a mixed number. Remember, if you're seeing it blurry, you need to go in the settings and raise the quality of the video, right? 19 divided by 3 as a mixed number. So 3 can go into 19 how many times? 3 can go into 19. 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 by 6 is 18. So 6 times remainder. 6 3s are 18, and that's a remainder of 1. So the remainder always goes over the divisor. So 6 and 1/3 is the answer. That's how we do mixed numbers. What I want to do, I don't know if you all will be interested in this idea. I create formula books for CXC subjects like maths, maths, physics, and all the formulae, and you can just use that to help revise. I want to gather all the techniques, formulae that you use that shows up like staple, like bread in the SEA exam and make it into a booklet. You all will be interested in that, and you could use it like a checklist while you're revising before the exam. And make it cheap, probably $150 or something like that. All the different things. So I'll be interested in that. Let me know. We're working on that. Arrange the numbers below in descending order. All right, so in descending order means start with the biggest. If you're going down the stairs, you need to start at the top of the stairs. It's descending order. Start with the biggest number. So the biggest number is, all of them have 4. Let's look at the next number. We always check this side. This has a 7. So it's 4, 7, 2, 3 is the biggest number. He's out. And then we're looking at the next one. Wait, we're still looking at this one. So 3 is here. Then 4, 3, 2, 7, right? And which one is bigger, 37 or 73? Because these both have 2 on them. So obviously 473, 4273 goes here. Then 4237. Got it? Got it? That's cool. Right? So you're going at a pace that, you know, everybody should be able to keep with. These are the easy questions. The first 20 questions normally go for 1 mark. Add 3.67 and 2.25. We line them up like this. Pay attention to those decimals. 5 and 7 is 12. Bring that 1 transported there. 1, 6, and 2 make 9. I don't have anything to bring there because it's just 9. And 3 and 2 make 5. So 5.92. That's a free max. So you're collecting them max, right? All the max secured. Press Y. Must CXC students know about this. Type Y in the chat. Y means yes. If you're getting them marks so far, everything good so far. Shade the fraction of the first shape to complete the statement below. Well, I'm seeing here that a quarter of the shape is shaded. A quarter of the shape is shaded. Don't mind to split it into, I don't know, 16ths. But this is 4/16 shading. And here we have a half shaded. So I am seeing, and I mean it's very easy to see that you actually need one more quarter to just make the half, right? That's not that bad. I don't think I need to go into any deep explanation with that. So shade him up there. And God is love. God is love. That's cool. So a quarter plus a quarter make a half. I like these questions. Little drawing things and things to help you in the exam. What is the time shown on the clock below? Time shown on the clock below. It is between, so with time, you always start off looking at the hour hand first, right? This is called an analog clock. It's not digital. It's not like 11:06 or something. This is a digital clock if you see it like this, right? Like an alarm clock, or the clock on your watch, or the time on your watch. This one, I am sure that it's pointing between 4 and 5. So if it's pointing between 4 and 5, the time must start with the first one that it is, 4. Right? So it starts at 4, and I'm seeing it's really close to 5. It's like quarter to 5. Well, I know that because this here. But what we do is we count how much numbers going this way and multiply it by 5. So there are 9 divisions, 9 spaces going that way. 9 by 5 is 45. That represents 45 minutes. Right? We don't know whether it's AM or PM. We don't know that. You can't tell that from this clock. Let's keep going. Let's keep going. In the diagram below, the length of each square is 1 centimeter. That's important for you to read these questions. You are going to get a question with a grid drawn on in the exam. And some of them are 1 centimeter grids. Some of them may be 2 centimeter grids or 3 centimeter grids. That's not unusual. It's important that you don't just jump to conclusion in this grid question. So what is the area of the triangle PQR? Well, the area of a triangle, I'm going to use the formula method, which you're not going to harp on in the exam. Half the base by the height. So it's half. The base is 1, 2, 3, 4. Half by 4, and the height is 1, 2, 3, 4. Half by 4 by 4. This is 4 by 4. Now, you could imagine little multiply signs between there, right? Half times 4 times 4. Half times 4 times 4. 4 times 4 is 16. So half of 16 is 8. So the area is 8 centimeters squared. That's one way to do it. Another way to do it is to envision that this is part of a square. And everybody knows that the area of a square is side by side. So 4 by 4, but it's actually half of the square. So it's 4 by 4 divided by 2. 2 by 4 is, once again, you get 8. That's another way to do it. The last way you can do this is to count up the squares. So 1, 2, 3, 4, 5, 6, and these two make 7, and these two make 8. Whatever makes your boat float, let your boat float with this. I need you all to press like on the video. If you see anybody commenting that they are seeing it blurry, let them know that they need to raise the settings on their end. So if you're not finding the like button, you need to close the live chat, press like. The reason I ask you all to press like is because YouTube will send it out to more. YouTube will send it out to more. YouTube will send it out to more students. I just have to block somebody who was typing some ridiculous things. Write the length of the cylinder. Let's go, let's go, let's go. Length of the cylinder. So you have the chance in measurement, in the measurement strand, in getting, did I miss out a question? No, I did not. You have the chance of getting a question like this. And I find students get it correct, but there's sometimes one or two students that kind of mess it up, you know? So there's one really simple way that I could advise you to approach this question. Find where the starting spot is. It's 21.5. You all agree with that? It's exactly between 21 and 22. So it's 21.5, 0.4, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 22. So 21.5, and this one stops precisely at 26. Subtract. So the higher minus the lower. You all good with that advice? Making the subtraction here, I would have had to borrow or take 1 from the ones column and send it into the tenths column here. So we have 10 minus 5 give me 5. 5 subtract 1. Remember, we are subtracting, gives me 4. And 2 subtract 2 is 0. So the answer is 4.5 centimeters. 4.5 centimeters. Lovely. We cooking with Ramco gas. Whoa, I see some 5.5. Another way we could do it, let me just go through this. Another way we could do it, I find again, you see how much different answers we get in the chat here, parents. This is one to watch out. Another way you could do it earlier is like if it starts at a nice little number like this, pretend this is 0 and like you're counting 1, 2, 3, 4. Well, that's not quite 5, that's half, so that's 4.5. How many of you all did it that way? You all do it that way? That's a nice way you could do it as well. That's a nice way you could do it. A jug and a cup are shown below. If the container is full of juice, we do something like this. How many cups of juice can be filled from the jug? So this one holds 250 mLs, and this one is holding 1 3/4 liters. Class, you need to change this liters to milliliters. And we know the trick with this. Because 1 liter is equal to 1,000 milliliters. And SEA loves to give you like a 1/4 liter, a 3/4. So we know that 1 3/4 liters, tell me if you all see this immediately, would be 1,750 milliliters. Because 3/4 of 1,000 is 750. 4 could go into this 250 times. 3 times 250 is 750. Check it out. Check it out. So really and truly, I could put 1750 milliliters here. And then I could be like 1750 milliliters. Now you notice with these questions, when you have different units, the aim in your life is to change it into the same unit. So it's as liters and milliliters. Listen to my voice. I hope you hear it in the exam. Change it into 1 unit. Don't try and do any weirdness unless it's 1 unit, right? Both of them has to be in the same units. Both of them will change to milliliters. Well, this one already came as a milliliter. So this divided by 250, that's 25 into 175. That may be weird for some of y'all, and some of y'all may see it immediately. A way you could help visualize this so that you could do a quick arithmetic is think of the 25. Think of the number 25 as 25 cents. And think of the 175 as $1.75. How many 25 cents can go into $1.75? and 75 cents. So 25 cents in a dollar, 4, and then 3.25 make 75 cents. So 175 is actually 7. So 25 could really go into 175 7 times. Some of you all may have seen that immediately from the beginning. Some of you all may have just changed this to a quarter in your mind and realize that there are 4 quarters in one, and then you have 3 quarters, and you say 4 and 3 make 7. How many of you all did it that way? Some of you all may have just spotted it one time. I see some people put the answer nearly immediately. And keep in mind, these are brand new questions. However, a certain number of students here are part of a Google Classroom where they get the questions on Monday and they get the chance to do it during the week. Our tutors correct it and they get the solutions back like today. So there's that. If you want to join that classroom, the number is in the description on this video. In the diagram below, the length of each square is 2 centimeters. Watch this one. They give the length of each square as 2 centimeters. It's different. The perimeter of the shape is 42 centimeters. They sure? Are they sure? Determine the length of the side PQ. Ooh, what a question. What a question. So the entire perimeter, if Blue Man, I didn't see Blue Man, they Blue Man here. If Blue Man walk around the shape and leave a trail of blue, Blue Man walk around the edge of the shape, they are saying that Blue Man will cover a distance of 42. I've seen some different answers. So the perimeter is 42 centimeters. That's the perimeter. And now they're asking us, what about this side? What is the length of this side? What is the length of this side? Oh boy, how are we finding that way? Well, I could do a little measuring here. Since this is 2, 2, 2, I know that this side must be 6 centimeters. And this is 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6. So this side is not 6, but 6 times 2 is 12 centimeters. This side is 1, 2, 3, 4, 5, 10 centimeters. What are we going to use? How are we going to conclude this? How are we going to conclude this? Well, perimeter is the complete distance around. Complete distance around. So the missing side, missings. We need to add up the side that we know. We know the 10, we know the 6, we know the 12. So that's 8, 28 so far. So the missing side, when we subtract, we must get up to 42. So PQ must be equal to 42 minus 28. Once again, we'll have to take a little borrow from you there. And get 4 here, get 1 there. And the answer is none other than 14 centimeters. So I just need to shout out a couple of people here who are doing really good work. If you find like the chat is a little distracting, you could always close the chat and focus on your work yourself. Nathaniel, Javon, all these people who got the answer 14. There's dozens and dozens of them. Big up on yourself. Well done on a Sunday, all you're grinding out. So we usually reach in the 400s in this. So shout out to the 400 of you all here today. Let's keep going. How many grams must be removed from A and placed on B to balance the scale? Now, you may be tempted to just subtract. How many of you all feeling to just subtract this and say that I go there? But if you do that, if you'd say 1300, take away 900, you get 400 grams. And I'm seeing that answer in the chat. I'm seeing that answer in the chat a lot. If you take this 400 grams, right, and you throw it here, what you think will happen? Now this one will turn to 1300, and this one will turn to 900, and the scale will still not be balanced. So 400 is wrong. Oh boy. So there are 2 ways to approach this question. 2 quick ways to approach this question. One is to add up the 2 weights, the 1300 and the 900, to find out how much we have in all. And in all, we have 0, 0, 9, and 3 is 12. Bring across the 1 like that. This 1 went there, the 2 went here, and we will get 22. So it means It means that we need to have 1100 on each side to balance it. You need to divide the 22 by 2. 1100 or 1100 on each side. So how much do we need to get rid of here to reach down to that balance? Well, we just need to, and y'all could see that immediately, you just need to get rid of 200. You all understand that? You understand the difference? So 200 grams will go here. That's the long way to do it. That's the simple, long way to do it, right? Yeah, there's another way you can do it. You can realize that the difference between the two of them is, we got this already, it's 400 grams. The difference between the two of them is 400 grams. So if there's a 400 difference, we need to balance it. It means only half of this needs to be sent there. You understand? So half of 400 is, of course, 200 must be sent this way, and 200 would remain there. So this, if this loses 200, it becomes 1100. This gets 200, it becomes 1100, and it balances. A simple but tricky little question. A simple but tricky little question. You could lose a mark silly day. Even a bright student could just, even a well-prepared student could just lose a mark there. Complete the bill shown below. All right. So if you have to complete a bill, you want to look down, see maybe they gave you the total. They did. They gave us the total. So what's our next step? If they give us the total, and it seems like we're just missing one, sometimes you'll have item and the quantity, meaning how much of the item you have, quantity, and then price. In this case, they just paid us as one item. So we're assuming it's just one of each, and the price. So you just need to add up all and subtract, right? And some of you all are experts when it comes to this. So let's add up these guys. So 1040, 125, 365, 5 and 5, make 10, 0, 1, 4 and 6 is 10, and 3 is 13. So the 1 comes over here. 1, 1, and 3 is 5. So we have 1530 so far. So far, the bill adds up to 1530. So the remaining number here must be what carries it to the 1815. So I can subtract. So bill so far, this is the bill so far. So I can subtract to find the missing cost. So the cost of 1 pen will have to be the 1815 minus the 1530 that we got so far. So if I take away 1 from this, I can give this one 1. And then I can take back away that 1, give this 10, and I'm just doing the long thing. Wait, I didn't need to do that. I didn't need to do that. Hold up. Because 0 from 5 is 0. Now I needed to borrow. Good thing this is an online class. You not to worry if I have corona or anything. 11 minus 3 is 8. Wait. 0 from 5 is 5. 0 from, what did I say? 0 from 5 is 0. 0 from 5 is 5. Oh, go on, boy. And then 3 from 11 is 8. Right. We're going good. There's a subtract here, right? 5 minus 0 is 5. Brought across 1, got 11. 11 minus 3. And now 7 minus 5, we have a nice 2. And the ones are done. So we have 2.85 here. Nice and great. Shout out to the people who got this immediately upon seeing the question. 2.85 is good. There would have been a dollar sign there. So the good thing about SE is that they give you the units, so you don't get penalized for forgetting units. Write down the name of the shape very quickly. Let me see the first person. Let me see the first person. Shouting out the first person to type this. Square base period. Shivani. And Shivani's from my class. Shivani, big up yourself. Some people was triangular base pyramid in the hustle. It is a square based pyramid. Right? Square based pyramid. The pyramids always have triangular sides going up to the top. Yeah. And it's square. So we kind of assuming that, because they didn't do anything to force us to believe that it was a square. And they probably would have to do that in SCA just to be, because if somebody put a rectangular base pyramid Who am I to disagree? Who told you that was a square? We're assuming that was a square, right? Or which angle in the shape below is less than right angle? I know all you love when they give all you these questions. Easy man thing. This is a right angle. This is a right angle. This is an obtuse. Remember the obtuse? Obtuse angles are more than 90 degrees and less than 180 degrees. So this is an obtuse. So which is less than a right angle. This is the only one that is less than the right angle. It's really small. It's the smallest of them all. That's an acute angle. Draw the line of symmetry in the letter below. The line of symmetry is a line that splits the object into two equal parts, and the parts, each part is a reflection of the other part, right? So it forms the reflection line for the object. So a straight line there would have done the trick. You can't say I come through the straight line, so you can't say I come through the straight line for you. Oh, wait. They didn't ask how much, they just asked the droid. What number does this box represent? So 13, 18, and 20 is the same as the mean of 19 and what? All right. So the mean of these three numbers is the same as the mean of these two numbers. How are we doing this one earlier? I'm trying to see if there's a shorter way we can do it. Let me do the long way first. So the long way, I would add up. That came there, because 3 and 8 make 11. And then add up again, and I got 51. And when I divide 51 by 3, because there are 3 items, I will get 3 into that is 17. So I got the mean of this being 17 is the mean. However, I also want the mean here to be the same. So the short, I am sure that this is 15. I didn't need to work it out. How do I know that? Because there's this thing with mean in my mind. If I know one of the numbers is 19, and I'm trying to get the mean to, let's put the mean in blue, to be 17, then the other number should be the equal distance going down here, so it should be 15. How many of you all knew mean could operate like that? You could use mean like the fulcrum on a seesaw, like the pivot on a seesaw. So you're balancing the two numbers the same distance apart. So that's like a really short way to see it. You all knew that? Or since we know that the mean is 17, we can say 17 times 2 must be the total when you add up these two guys. 17 times 2 is none other than 34. So now you say 34 minus 19 would give us the 15 that we are looking for, which is your other number. So when you have to find the mean of two numbers, or you are given the mean of two numbers, let's just pull on the side. Let me just investigate that little trick that could give you some speed in the exam. Let's say there's this number, right? And this number is 21. And I told you that the mean is the mean of two numbers, and there's another number. And I gave you the mean here to be 17. What do you think the other number is? What's the other number? What do you think the other number is? Well, the distance from 21 from 17 is 4. So I need to go 4 down. I need to subtract 4 down to kind of balance it, and that'd be my other number there. My other number is 13. And think about it. If I add 13 and 21 together, I will get 34. And when I divide this by 2, I will get back my mean. Remember, the mean is the sum of the numbers divided by 2. Something to think about, something to play around with. This comes in handy when you're thinking about mean. You can think of it as the middle of all the numbers. So even if I told you one more trick, even if I told you, and I've seen these coming like even CSEC exams, if I told you I have 3 numbers, 21, 25, and 29, can you quickly tell me what the mean of these 3 numbers are? Anybody could quickly tell me what the mean of these 3 numbers is? I will just leave that for you all to think and consider. I'm not even going to talk about it. So I'm just going to leave this. Can you, without adding up, quickly tell me what the mean of these three numbers are? So I could come back to this video and ponder that. There are 30 students in a class. The income mean means average, right? The incomplete tally chart below shows the favorite animal chosen by the students. So what I would do in this case, guys, is write a little frequency column here. Frequency is where you write the actual number. 25 is correct. Those of you who seen 25 from the question before that, the little trick question I give you. 11, we don't know. What's this? 5, 6, 7, 8, 8. You all know the count your tallies, right? 1, 2, 3, 4, 4. So we have 4, 11, 8, and 4 so far. So far, the students so far, we have how many? Students without, wait, panda not included. No panda. Panda. Would be 11 plus 8. I can do this in my mind. 11 plus 8 is 19, plus 4 is 23. So that's 23 students. However, there are 30 students in all. So I immediately know somebody is missing, and I can figure out how many is missing now. Because 30 minus 23, in my mind, I'm seeing 7 students were not accounted for. So this was another question where how many of these questions we do so far, where we add up? No, that's 8. Let me zoom in so you can make sure and see it's 8. Director, zoom in. 5, 6, 7, 8. Right? So somebody else questioning whether it's 9 or not. So I know 7 should go there. 1, 2, 3, 4, 5, 6, 7. Cooking with Ramco gas. Now, if you write 7 here, you get no marks. You have to actually put it in the tally styling to do the thing proper. So how many students choose panda? Oh, no, they asked it here. So yes, you could put 7. They asked it here earlier. You could write 7 here, 7 students. But if you actually to complete the tally table, you would put the tally marking there this time. A nice little mixed number subtraction here. There are 2 ways that students do this. One is to change this to improper fractions and then do the LCM. That's like the long way. If you are accustomed with your whole number separate, then do the fraction. That may be shorter in some cases. So let's do the mixed number. So changing this to mixed number, 3 by 3 is 9 plus 2 is 11. I'll repeat it just now, right? 11 over 3. So to change a mixed number to an improper fraction, you multiply the whole by the denominator, the whole number by the denominator. 3 by 3 is 9, and you add it to the numerator. 9 plus 2 is 11, and that finds its home right there. That's 11. And similarly, you would end up with 2 by 6 is 12. You'll end up with 13 over 6. Your next step is to find the LCM. To create equivalent fractions, we can find the LCM of the denominator. Equivalent fractions just mean we want a fraction that's equal to this fraction, but we want the denominator to be the same as this denominator. So the LCM of 6 and 3 is not 18. I am actually seeing that the LCM of 3 and 6 is 6, because 6 could go into 6 and 3 could go into 6. So I might as well just put 6 here. And since this is multiplying by 2, a factor of 2, I would have to multiply the numerator by a factor of 2. How many of you are familiar and comfortable with this style of working? How many of you are good with this? This is an ideal class. The Sunday revision is an ideal thing to see areas you're weak in, and during the week you strengthen up on your fractions and your mixed numbers and things. You practice doing this a million times. So now, because both of them have the same denominator, right? Because they have the same denominator, we could just subtract the numerator in big. We can see that in big now. So 22 minus 13 is 9 over 6. 9 over 6, we could break this down. 3 could go into that 2 times. 3 could go into that 3 times. We have 3 over 2. Or we can put our answer as 1.5. And since they gave us one set of mixed numbers, we can hit them like a mixed number too. Another method is to deal with the wholes. So the wholes are 3 and 2. So we say 3 minus 2 is equal to 1. We're done with the wholes. Now deal with the fractions. How many of you are familiar with this method, or are you a pro in both methods? You say 2/3 minus 1/6. Sometimes something weird happens here, like maybe this fraction might be small and this one big, and you start to actually borrow from the whole that you got. But that's not going to happen here. So 2/3 minus 1/6 is the same as you're doing the same LCM fancy thing here, boy. So 6 is the LCM, multiply by 2, so this is 4/6. 4/6 minus 1/6 is 3/6. So if you look very carefully, you would realize that we have our fraction, we have our whole, we are finished, and you can bring it together to find the answer, which is 1, and 3/6 is the same as a half. All right, we just completed 21 questions. Rate out of 10 how much you understand those 21 questions. Most of the questions, if there's two main methods, I will show you the two main methods that students in schools in Trinidad do it. We're about to go into the next. Well, I kind of already do set the first part of the first question in section 2 already. So the rating's looking good. You can really test yourself every week by getting next week's paper is already done up. The paper that I'm going to do next week Sunday, we already do it up. So you can get that paper tomorrow. Those of you in the Google Classroom, I need you all to do your sample exam and hand it up before Saturday so you could get it corrected, so you could pace yourself. The thing with sample questions you may get elsewhere, you may not be able to get it corrected. So if you are one and not getting it corrected, you can sign up to the class and get it corrected, that kind of thing. The number to sign up is in the description of the video. Let's keep going. So boom. 3/7 of a number is 18. What is half of the same number? So 3/7 of some number is equal to 18. So we need to find the same number. We need to find the number. We need to find the number and then get half of it. 3/7 of some number earlier is 18. So one thing that is going to come in SEA, guaranteed, parents, is finding the whole. A principle called finding the whole. If I'm getting out this book with the formulas and the different types of questions, this is definitely one thing I'll put in that revision checklist or whatever I'll call the book. Finding the whole is going to come. So if you have to find the whole, the technique is understanding how reciprocal works, inversion works. 3/7 here is actually a fraction that's representing 18. So 3/7 is representing 18. To find the whole, the 7/7, it's going to be, so this is just represent the whole, the 7/7, it's going to be the inversion. Because you'll need to divide this by 3 to find 1/7 and then multiply by 7 to find 7/7. So in essence, or in short, what you are doing is multiplying by the reciprocal of the fraction that's representing the number. And this will give us 3 into 18 is 6, 6/7 are 42. So the number, this mystery number, is 42. And half of the mystery number, half of the same number, half of the 42 is 21. That's how you do this question. It's going to come some way or the other. This fraction question is going to come. An auditorium has 9 rows. Each row has 25 seats. All the seats in 8 rows were completely occupied with 7 seats in the 9th row. Well, I lost track of what I was saying. Let me start over. So some auditorium has 9 rows. Each row has 25 seats. All the seats in the 8th row, somewhere down there, were completely occupied, while 7 seats in the 9th row were not occupied. How many seats were occupied altogether? This question running me all over the place to just ask me some easy man thing, boy. All the seats in 8 rows were completely occupied. So 25 seats in each row. Each row have 25 seats, right? and all the seats in 8 of these rows were occupied. So first 8, I feel that's an easier way to do this, would be 8 times 25, and 8 times 25 in my mind is quickly 200, because that's like 4 times 25 is 100, so 8 times 25 is 200, but completely occupied was 7 seats in the 9th row were not occupied. This word here is a tricky little word, boy. 7 seats in the 9th row were not occupied. So how many seats were occupied? Occupied was 25 minus 7. And 25 minus 7 is how much, class? Is that 18? 18 plus 7 makes back 25. So 18 seats occupied in the 9th row, 200 occupied in the first 8 rows. Altogether now, 218 when you add it up. Well done, well done, well done, well done. Diana painted 75 circles of 3 different colors. Red, blue, and green. There are 15 green circles and an equal number of red and blue circles. What percentage of the circles are blue? Well, if there are 15 green circles and an equal number of red and blue, so there's red, there's blue. I always use my columns to represent the number of circles or the frequency. Number of circles. So the number of circles, red, you understand the column is like the height, and number of circles blue are equal, and the number of circles green, well, we don't even need to draw a column. We could just write 15. We know this number. So in this case, we want to remove the excess, the one that we know about, because these are shared up equally. This makes it unequal. So it's an unequal sharing, something that's going on here. So if we remove the greens, why is this painting all these green and red and blue circles? I see it's have people doing strange things out here. So if we remove the green, we will have how many circles now? 75 minus 15, it's equal to 60 circles, right? You remove the green circles. There are 15 green circles and an equal number of red and blue circles. So 60 circles, and these 60 circles represent the equal number of red and blue that were red, blue, the 15, red, blue, green. I remove the green, and now I just have the equal number of red and blue. So to find how many blue, I divide this by 2. So blue circles, since I have two parts now, 2 equal parts, would be equal to 60 divided by 2, which is 30 circles. So there are 30 circles. What's the question? What percentage of the circles are blue? So 30 over 75 multiplied by 100 over 1. That's how you find percentage. You represent the fraction. So how much over the total multiplied by 100 over 1, because we're doing percentages. And 25 can go into 100 4 times. 25 can go into 75 3 times. 3 can go into 30 10 times. 10 times 4 is 40%. Shout out to the people who had this in the chat from way before. Why is in the chat if you understand? Or just type, I understand. I understand. I see the light. 40%. Let's keep going. Let's keep going. So the sum of Ali, Barry, and Chelsea's ages is, this kind of thing, a math teacher like me, I doesn't really know if that the right English. Any English teacher out here? Sure, this always right this way. Any English teacher out here could say, yeah, that's cool. The sum of Ali, Barry, and Chelsea's ages is, I guess this is going with the subject verb agreement here is we dealing with the sum. The sum of blah 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 is. The sum of da 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 is. Yeah, that's something correct. Not So the sum of Ali, Barry, and Chelsea's ages is 56. Yeah, the sum is 56. Barry is 14 years older than Ali. So another unequal boy. When you see unequal share, now you're supposed to get happy. You're supposed to just gears up your diagram one time. Barry is 14 years older than Ali, and Chelsea is 18 years older than Ali. So I feel earlier, I'm going to start with Ali. So Ali will get this first bar here. You understand how we do the bars now, right? You've seen me doing the bars. Is the third side they're doing these bars in unequal sharing. Let's put Barry here. Barry. Ali was a name of somebody in the C-Sec maths exam last year. Or was it? Yeah, I think it's last year. Barry is 14 years older than Ali. So Barry gets Ali's column plus 14. A little 14 boost going up there. You're understanding how we're going to take this down. Chelsea gets Ali's column again because Chelsea is 18 years, but Chelsea has an 18 boost going on there. So Chelsea is the same as Ali plus 18. Barry is the same plus 14. So you all understand what we need to do. In unequal sharing, one of the key concepts is removing the excess. So removing excess to get it equal, these three equal parts, we'd have to remove 14 plus 18. So the excess here, excess age, whatever, it's 14 plus 18, which is 4 and 8 is 12. 32. So removing the 32 extra years here, it will be 56 minus 32 is 2 from the 6 is 4, 3 from the 5 is 2, 24 years between the three. You all understand it? Once you start to understand unequal sharing, you're ready for them. You're excited to see this question. You're excited to see this question. So Barry's 14 years older. Let's get rid of that 14 years older. Let's get rid of that 18 years older. Remove that excess. So now it, in effect, it comes like if we have, that's not, there's something vibrating here. It comes like if we have 3 ages, 3 Alis. You all seeing that? It's like if we have 3 Alis, Ali, Ali, Ali. So I can say Ali's age, or one of the blocks, is going to be 24 divided by 3, which is 8 years old. And we could also figure out Barry's age and Chelsea's age. If they want that, we could do that. They want that? Yeah, look, they want that down here. So Chelsea's age is Ali's age, the 8 plus the 18. 8 plus 18 is equal to 26 years old. I want the people that are watching this, we go in, I believe we have 12 revision sessions to do before SE. I want the people that stay in with me every Sunday. By the time exam reach, all the questions must feel like you do it a million times before. It must feel easy. The style of questions must feel repetitive. When them correcting your people, they must say, wow, the nation is brilliant. The nation is brilliant. So practice this unequal sharing style. Practice it, my people. All right. So 26 years old is good. 26 years old. If you all catch it, put cake and ice cream in the chat. The cost of a radio is $640 plus 12%, 12.5% VAT. Now, this probably won't show up in your exam, but we're still going to do it. So 640 plus 12.5% VAT. So 12.5% VAT. Now, 12.5 is what is a percentage? There's something called the eighth family. Let's talk about the eighth family, because you need to know the eighth family. The eighth family speaks about the eighth fraction. So we have 1/8, we have 2/8, we have 3/8, we have 4/8, we have 5/8, we have 6/8. How many of you all know your eighth family inside out? You draw this up sometime in your school life, you hang it up in your room, you put it on your pillow. 7/8. And if we want to express this as a percentage, as a decimal, let's do decimal first. 0.125. You all know that? 0.25. You could put a 0 there, or you can leave it. This is 0.375. You all know this? 0.5, 0.625, 0.750, 0.875. Yeah, that's correct. And then, of course, 1. You all hang this up in your room. Parents, they do this already. They have this written somewhere. This is memorized. Really and truly, this one is really a quarter. This one is really a half. This one is really 3/4. That's why we get the 0.75, 0.5, 0.25. Just saying. And if we want to change it as a percentage now, the percentage, this one is as a decimal. If we want to do it as a percentage, it will be 12.5% or 25%, which is a quarter, 37.5%, 50%, 62.5%, 75%, 87.5%, and of course, none other than what? 100%. So this is your eighth family here. And if you're feeling table-ish, you can hit them a nice little table, boom, bang, bang. No way again, me to draw no straight line for no table and thing here. That would take too long. But you have your eighth family. You watch it every morning. Make sure you're feeling good about that. Obviously, you have your quarters. You have your fifth family, sixth, your thirds. You need to know them. But one of the more complicated ones is the eighth. And the only thing you really need to memorize, I feel, is this guy, this guy, this guy. These really are the newbies. So let's go back, and this one, of course. So let's go back to the question. Now we know anytime we see 12.5%, we are really thinking 1/8. Anytime you see 12.5%, 1/8. 12.5% is the first member of the eighth family. 1/8. So if the cost of the radio is 640 plus 1/8 VAT, you are going to work out your VAT now, value added tax. It's 1/8 of the 640. And we know 8 could go into 64 8 times. So this is really 8 plus the 0, $80. So therefore, the cost of the radio, you see how easy it gets when you know your eighth family? Cost of the radio is equal to the 80 plus the 640. 640 plus the 80. It's going to be 8 and 4 is 12. Bring over the 1. That went there, that went there. $720. That's the cost of the radio. We add on 1/8 or 12.5%. Let me keep it pumping. How many pieces of tape, each of length 25, can be cut from a 7? This is in meters. This is in centimeters. The first instinct to fix this question is to change the meters to centimeters. Or maybe this to meters, but that sounds a little more complicated, decimals and things. So let me change this one to centimeters. A quarter, it's the same as 7.25. A quarter of a meter is how many centimeters? Remember, a quarter of 1 meter is the same as a quarter of 100 centimeters. There are 100 centimeters in 1 meter. A quarter of 100 is none other than 25 centimeters. 7 meters is 700 centimeters. So 7.25, and I know a bunch of you all could do this in your mind, 7.25 meters is the equivalent of 725 centimeters. Now we are ready to divide by 25. Dividing by 25 came a lot in this paper, boy. We get to exercise our dividing by 25 skills. Now, a shortcut, since we have it so much, let's go talk about dividing by 25 in the corner here. Let's go talk about a trick. Dividing by 25. Dividing by 25. Chances are this will show up itself in your exam. You all know the trick of divided by 25? If you have 100 and you divide it by 25, everybody should know that that is 4. 25 could go into 100 4 times. So anytime now they decide to do you this in the paper and say like maybe 700 divided by 25, we know for every 100 there are 4 25s in them. Every 100 there are 4 25s in them. So 700 means 7 20 by 4, 7 4s. So when you say divide by 25, when you give me hundreds here, bro, I already know, well, every 100 is 4 25s. That's 7 of them. 7 by 4. So that's 28. Yeah, y'all understand that? Or if they give you something like maybe 500 divided by 25. 25 could go into 100 4 times. There are 5 hundreds here. 25 could go into 100 4 times. And there are 500s here. So this is the same as 5 times 4. 20. Let that sink in. Come back and watch this again and let it sink in. Let it sink in deep, deep, deep. So now we have 725 divided by 25. We know 25 can go into 700. Ignore the 25. 25 can go into, if this was just 700, 25 could go into this 28 times, right? 7 4s are 28. And well, there's a 125 here, so 28 and 1 is 29. Of course, you could always say 5 into this 5, 5 into this 1, remainder 2, 5 into 22, 4, remainder 2, 5 into 25, 5, 5 into this 1, 5 into this 2, remainder 4, 5 into 45, 9. You ended up with 29 here. Yeah, you can break it down as well. But it helps to be able to see how to divide by 25 quickly. You can visualize answers faster. Complete. All right, so there's the part in the paper where we take a little break and you always just watch me draw things, complete the shape. Always make sure you read the question properly. Next thing had little tricks. Next thing they wanted you to draw next line as symmetry and thing. Seems like they just want me to finish up the shape here. It went down 2 this way, so I'll let it go up 2 this way. Then it went down 2 squares, 2 squares. So like 2 squares, 2 squares. It should bounce up that peak there and come back down, make that peak there. This is 2 this way, 2 this way. You all seen it? Making sense? How many it goes down here? It goes down 1, 2, 3, 4, 5. So it should go back up here. 1, 2, 3, 4, 5. It should be a perfect reflection. Yeah, and that's that. So all my points look like they're doing it nicely. Obviously, you'd be using your ruler, straight lines. Boom, bang, 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 bang. Complete the shape. We did it. We did it. Poking it around. Focus. The pictograph below shows the favorite subject shown by 60 students. How many students chose English as their favorite? The pictograph comes like 2 or 3 ways. Pictograph comes like 2 or 3 ways. This is one of the way a pictograph can come. They can give you the number of students and no key. Notice there's no key. What is the key? The key is like if they give you the heart and tell you 1 heart means 5 students, there's no key. So you need to figure out the key. If you are not given a key, figuring out the key works like this. If you are not given a key, figuring out the key, you need to add up how many shapes you have. So let's begin adding up these shapes. 1, 2, 3, 4, 5, 6, 7. Half and half makes 7. 7.5. We have 7.5 shapes. You have 7.5 shapes. And these 7.5 shapes, is that correct? Represent 60 students. 7.5 shapes represent 60 students. Let's just double check this. 1, 2, 3, 4, 5, 6, 7, 7.5. So how much does 1 shape represent? If 7.5 shape means 60, how much does 1 shape represent? $60 divided by 7.5. So 60 divided by 7.5 looks a little rough. 60 divided by 7.5. How are we going to do it? 60 divided by 7.5. It looks rough. How? How are we doing this? 60 divided by 7.5. How are we doing this earlier? Well, a shortcut with these decimals, if you have 60 divided by 7.5, one tip that you can do that may really help this situation is to move the point away, back here. But if you move the point on the denominator, you should move it also on the numerator. The point is here, so it goes there. So I could think of this as 600 divided by 75. You all understand that? And then 5 can go into this. 5 can go into this. Verify 5 can go into this 15 times. 5 into 7, 1. Remainder 2. 5 into 25, 15. And 5 can go into this. 5 can go into this. 5 goes into this 1, remainder 1, 5 could go into this 2, 120 times. And then once again, I can say I can go directly 15, or I can break it down. 5 into this is 3. Let's do the 3 first. 3 into this is 5, and 3 into this is 4, and then 5 could go into the 48. So 7.5 can go into 68 times. And that answer was being shouted by many in the chat. So it means that 1 heart represents 8 students. That's why we have 7.5 hearts making 60. That's not it yet. We need to find how many students chose English as their favorite subject. Well, 1 heart means 8. Half of a heart would mean 4. So 8 plus 4 is 12 students. Mr. Vincent, stop spamming my chat, please. We are on to number 30. Draw a quadrilateral with 2 pairs of parallel sides and no right angles. 2 pairs of parallel sides and no right angles. That could only be, I'm not going to say what it is, but I'm going to draw it. I'm not going to say what it is. 2 pairs of parallel sides. So this is parallel. This side is parallel. This is parallel. This is parallel. So that's my shape there. Notice how none of them are right angles, right? Notice it. This is not a right angle. It's acute. This is obtuse. No right angles. Use rulers. And that is, yes, you could also say rhombus. You could also create a rhombus, but if you're doing the rhombus, well, this must be a right angle here. So a rhombus would look more like this. Not a kite. Rhombus. Special type of parallelogram, but simple. We could go with parallelogram. Trick to spelling parallelogram. The L's kind of line up to make a parallel thing too. Parallelogram. All right. Parallelogram. Let's keep it rolling. Number 31. Sophia has, zooming in just now, I just kind of snapping it. Sophia has this solid shown below made up of 4 equilateral triangles. Each edge measures 7 centimeters. Write the name of the solid. What's the name of this solid? Shivani, real quick in these names, boy. Triangular pyramid is correct. Triangular pyramid. Anybody who just touched on, did you press the like yet? How many likes you have in the chat? I can't see it in the video. I can't see it on my thing. Tell me how much likes we have there. And if you didn't press like, press it now. How many likes do we have? Let's get this video shared more. 285. No. You have 466 people watching here. So let's get that up. Or let make it go up. What is the total length of all the edges? Well, I guess we need to start counting up edges to get this next part. Let's count up the edges. 1, 2, 3, 4, 5, 6. 6 edges, and each one is 7 centimeters. So the total length, we're going up, we have 340 something likes now. The total length of all the edges would be, how much sides I get? 6 sides, 7, 6 sides, 1, 2, 3, 4, 5, 6 sides. 6 sides. And one side is equal to 7 centimeters. So 6 side will be 6 times 7, 42 centimeters. It's total length of all the edges. All right, so we kind of going up in the likes. We're still short of likes, so they keep pressing the like button. Sophia drew 8 circles on each face. How many circles did she draw? Wow, Sophia, you have time to draw 8 circles on each face? Well, I count how many faces we have. We have this. We have this face here, 1. Then we have this face here, 2. Let's draw it a little neater. We have this face here, 2. We have the base. The base is the face that's underneath there, 3. And then it seems like we have a big triangle in the background. You all see the big triangle in the background? That's 4. You all see the big triangle in the back there? In the back. That's the 4th face. So we have 4 faces, and if she's drawing 8 triangles on each face, 8 circles, sorry, on each face. So one face is equal to 8 circles. Therefore, how many faces? I forget. 4 faces. 4 faces would be equal to 8 times 4 equal to 32 circles. 32 circles. Let's go, let's go, let's go. A solid has 12 edges. A part of the solid is drawn below. Complete the drawing. 12 edges. I just go in and hope that it was a cuboid. Let's see if I'm correct. Don't tell her, yeah. Tell her your parents. That's how I'm doing it here. We hoping. All right, so let's go 1, 2, 3. All right, so let me count up these edges. I'm counting the edges, not erasing them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I knew that. Cuboid must have 12 edges, so we good. How many vertices are there in the solid? You see how nice they could test you on these little simple things? Vertices mean the pointy thing, right? The tricky part, the part that if you pelt somebody, you can hit them real hard. So it seems to me that there are 8 of them. 8 pointy parts, 8 vertices. So that's like 3 marks for me. 8. EIGHT, 8. You ever sit down in an exam room doing your exam, good, and then all of a sudden you remember, you realize you forget how to spell the word 8. The diagram below represents a container. Calculate the volume of the container. So the chances of this coming in your exam is low. They might have kick up if they bring this because they're not supposed to bring any formula volume. But we're still learning it for in the future if people watching this video, when we out of this current framework that we have for the pandemic and they bring back the whole essay. So it's going to be volume is equal to length by base by height, or length by breadth by height. So it's 70 times 30 times 20, or I can think of 7 by 3 by 2. 7 3s are 21 by 2 is 42. And then give me back those zeros, bro. So this is 42000. Right? So that's the volume of the container. And that would be in centimeters cubed. You could multiply this all your ways and see if you get that same number. How many liters of water will the container be able to hold? How many liters make 1 cm cube? Ooh, they had a little trick there too. Watch that trick there. Yeah? So 1 liter contains 1,000 centimeters cube. 1 liter has 1,000 millimeters and 1,000 centimeter cube. Same thing. 1 milliliter is the same as 1 centimeter. So make sure you're good with this. You're good? You're good with this? I said I'm good with you. All right, so if 1 liter is 1,000 centimeter cube, how many liters we have here, boy? So this is the same as 420,000 divided by 1,000. You could just cross out them zeros, or you could have moved the point back 3 times, 1, 2, 3. We just still get the same thing. This represents 42 liters. That's not the answer. That's not the answer. The answer is saying that it's 1/3 fill. 1/3. So we need 1/3 of the 42 liters, which is it when it's full. 1/3, hey, I say 1/3 and right a half, boy. A short circuit in here now. 1/3 multiplied by 42 over 1. It's equal to 14 liters. 3 can go into 42 14 times. I just seen somebody comments. Alia, what we likes stated now? We likes gone up. We gonna by 100 any likes. The people them do anything? They press any likes now? They pay their fees? That the fees. That the fee for YouTube. Yeah, they press like. For an art project, a student is required to draw a rectangle that is 20 centimeters long and 12 centimeters wide. All right. I wonder why they draw it sideways. So calculate the perimeter of the shape that the student is required to draw. To this student, by anyhow, so 12, 20. So 20, 20, 12, 12, 20, 20, 12, 12. We can literally add it up without even thinking about formula. So 4 and 6 here, 64 centimeters. 64 centimeters. That's it. The student places stickers 4 centimeters apart along the outline of the shape. How many stickers are needed? Oh, 4 centimeters apart along the outline of the shape. So let's just consider this to see what's going on here. 4 centimeters apart along the outline of the shape. How many you think? Should we just divide clean and hope for the best? Now, normally when it's a circular distance question, distance pattern question, you could just divide. But let's prove it. Let's literally put these stickers down one by one. And then next time you'd know for sure. So a sticker will go here. How many stickers will go here? There are 20 centimeters here and they are 4 centimeters apart. So we will have 1, 2, 3, 4. 1, 2, 3, 4. 4 centimeters, 4. 1, 2, 3, 4, 5. So 5 fours are 20. So we did that. And this side will have the same setup. I'll literally put it down these stickers so you can see it, right? So 1, 2, 3, 4, 5, 6, 7. How many centimeters apart these stickers are? 4 centimeters apart. So this is 4, 4, 4, 4, 4 centimeters. This makes the 20 here. So count how much stickers we have so far. And now these stickers need to be 4 centimeters apart to make 12. So 4, 4, 4 make 12. So I literally putting down these stickers on the diagram earlier. Boom, bang. Now count up all these stickers I have. Mr. Kerwin Springer stuck on this YouTube video here. 1, we starting there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 stickers. 18 stickers. You got calculate the perimeter. Let me just make sure I did this correct. The students place stickers 4 centimeters apart along the outline of the shape. How many stickers are needed? Wow. That is creepy. This distance pattern question, I need to include this in the book. 64 divided by 4 is 16. But that was if we was going like this. Oh, did I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Did I make a mistake here, boy? 1, 2, 3, 4, 5. Oh, yes, I did. I make a mistake. I thought I broke mathematics here, boy. I thought I break mathematics here. How come I have 6 spaces here? How come I was getting 1, 2, 3, 4, 5, 6? I was getting 6 spaces. I was supposed to be getting 5. 1, 2, 3, 4. Yes. 1, 2, 3, 4, 5. That's it there. Now we could count these stickers. Count them now. And let me hope for the best. 1, 2, 3, 4, 5, 6. That making sense. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. This is what I know. So when this shape is enclosed, you can divide normal. When the shape is enclosed, you can divide normal. Good thing I did this. So this was a learning experience. Now, how did I place? How I know how to place these stickers? Well, these stickers are 4 centimeters apart. So 4, 4, 4, 4, 4, 4, 4, 4, 4, 4 5s are 20. I don't know how I did that just now, and I put 6. That'd be interesting to watch rugby video and see what's going on in my mind. But anyway, the answer is a solid 16 centimeters. However, these distance pattern questions, right? There's something I want to tell you about these distance pattern questions. If it's enclosed, you could just divide like that. So 4 centimeters apart, Just divide the 64. If it's not enclosed, if the 64 was this, then the number of spaces is usually one less than the number of individual stickers or poles or that you want. Understand what I'm saying? Hopefully we come across a question similar to this. These questions with the wires and things. This is the one for sure I will put in. Calculate the total area of the placard. The diagram below shows a placard. No longer I hear that word placard with a shaded border. The border is 2 centimeters wide on all sides. So one of the things that students do in this shape thing is when they add it back on to make the big one, to make the biggie, they say, all right, it's 2 centimeters wide, so I need to add on 2 to this and I'll get 14 centimeters. Why is that wrong? Why is that wrong, class? Why is that wrong? Because yes, you want the big dimensions for the big rectangles, so you can just work out the two of them and subtract the total area of the placard. Total area is going to be, you know, it's not add 2 because you have this piece here, and then what about this piece? You added one side. Well done, Melissa. Well done. You added one side, so it has to be 2 plus, so it's 16 centimeters. So it's 12 plus the 2 from this side and 2 from this. Similarly, you add 2 from this side and 2 from this side until the 21, and you will get 25 centimeters. You all understand? Yes. So you would add 4, yes, 2 on either side. Just so this man jump out. I just watch Attack of Titan. Rudy, we're not talking about that. So the total area is going to be 25 times 16. Now, this is a 4 could go into this. And 4 by this is 100. This is 4 4s. So I know this is immediately 400. You understand what happened there? You could work it out. Remember, 4 times 25 is 100. And there are 4 4s in 16. So I know this is 400. So the total area is 400 centimeters squared. That's the total area of the placard. What would be what is the area of the border? Well, I need to find the area of the small rectangle. Area of smaller rectangle is the length by breadth, or the length by width. So it's the 21 times the 12. Was it 12? 21 times 12. Very quickly, this is 252. So the area of the border, is going to be the biggie minus the 252. Oh gosh, they're going off on this Attack on Titans thing. How much y'all getting? The area of the border. So it's 12 by 21 is the small. You get 252, right. And when you subtract, y'all keeping up with me? You will get 841. So the area of the border is 148 centimeters squared. 148 centimeters squared. Let's keep going. So Mr. Kim borrowed $7,200 from the bank at 4% interest per annum for 2 years. How much interest did he pay? This isn't coming for your exam. I'll do this really quickly. Principal by rate by time over 100. This is going to be 72. That the principal is the lump sum that you put in, multiply by rate, 4 as a percentage, multiply by the number of years over 100. Any of you all ever do this before? Or your teacher say this is not coming, we never doing this again. But you will do it in secondary school. This is really 72 times 8. Let's just put 72 times 8 here one time. 8 2s are 16. You're not getting this in your exam. That's true. 1 8 by 7 is 56, 57. So again, 576. Anybody know how to do this still? Just for kicks? Just once, you just touch it a little bit in school just in case. Mr. Kim repaid the loan in equal monthly payments. Calculate his monthly payment. Equal monthly payments Mr. Kim borrowed 72 from the bank at 4% interest per annum for 2 years. Well, his monthly payment will be the total. Yeah, and I need to get the amount. So it will be the 7200. Those of y'all, this is just for the future people. Future people, right? So 7, when I add up that, I will get 7776. And I need to divide this by the number of months. The number of months is 24. Number of months going to be equal to 7776 divided by 24. I'm not going to waste time on this. And what will that be? 324. 7776 divided by 24. 324 is correct. This is going to be 324. 324. All right, so this is not coming for exam. Let's move on to the next question. Future people, if you're watching this, good luck with that in the future. Let's go here. Number 37, a group of students uses seashells to create a pattern. The number of seashells used form a pattern as shown below. So item number 1 has 2. Item number 2 has 4, 8, 16, 32. So what are they doing? This is like 2 times 1. It's like 2 times 2. This is like 2 times 2 times 2. It's like 2. You all seen this? Times 2 times 2. 2 times 2 times 2 times 2 times 2. I'm sure you all do this in your mind before. Like you say, 1 by 2 is 2. 2 by 2 is 4. 4 by 2 is 8. 8 by 2 is 16. 16 by 2 is 32. You all ever do that doubles game? There's a game on Google Play and the App Store that I could play with that. The name of the game is 2046. I'll go and look it up afterwards. Although your parent might say you downloaded the game and you're like, no, but this game is actually an educational game. So 2046. You go and check it out. And you keep doubling 64, 128, 256, 512 going up the road. As you know that game? Let's be moving the squares. Anyhow, this is the pattern that they're doing here. So the pattern rule is we can say each new item is twice the previous item. That's good enough. I will give you a mark so that you understand what you're saying. So therefore, like item 5 is equal to 2 times item 4, and so on. So each new pattern you keep adding in and next multiply by 2. You all good with that? Biddy, 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 boom. Using the same rule, how many seashells will be used to make item number 7? Well, item number 7 will have how many 2's in it? Item number 7 will have 7 2's. 2 multiplied by itself 7 times. Woo boy, this looking like it's going to be some bacchanal here. 1, 2, 3, 4, 5, 6, 7. So this is going to be 2 by 2 is 4. By 2 is 8. By 2 is 16. By 2 is 32. By 2 is 64. By 2 is 128. Those of y'all who got the 128 really quickly, that's good. Now, y'all will learn something in secondary school that this is, we could write this like 2 to the power of 7. That's coming up in secondary school. 128. Let's keep going. We're going on to the beautiful part C. I thought you was going on to a new number. For which item will 256 seashells be used? The 8th item. Guess how I know that so fast? Because we were just on the 7th item with 128. And if I multiply this by 2, boom. So that had to be the 8th one because I hit my next multiply by 2. Are you keeping all your head on here? Nice, nice, nice. The group decided to use 384 seashells to make 2 items. Which item belong? That's not, eh? With each item being made from more than 100 seashells. How many seashells will they use for each item? Well, if you're using more than 100, it means that you're either using 126 or 256 or so on. Each item being made from more than 100 seashells. How many seashells will be used for each item? I'm not too sure with this question. They're making 2 items. They might have to make 2 of these because they can't make this. Because if you make this, you wouldn't have enough to make. Would you have enough? Would you have enough? 126 plus 256. 6 and 6 is why else in division by 2? The group decides to use 384 seashells to make 2 items, with each item being made from 100 seashells. How many seashells will be used for each item? Division by 2. Because the item could only follow these numbers. The items made could only follow these numbers: 2, 4, 8, 6, 2, 4, 8, 16, sorry, 32, 64, 128, 256, 512, and so on. The items could only follow these numbers now. So I know you're saying 192 when you divide it by 2, but you can't make an item with 192 seashells. It must follow these numbers to create the pattern. That's what I'm saying. That's what I'm saying. So the only possible items that this person can make with that number of seashells, the only possible items I'm seeing. This question a little ambiguous. Yet research what that would mean. Ambiguous. Let's see if they can make a 120. Is 128, 128, and a 256. 8. Yes, they can. I was saying 126. So they can make a 128 and a 256. So 128 and 256 adds back to 384. So they can make a 128 item and a 256 item. So 128 seashells for the first one and 256 for the second one. So don't just divide by 2 here. That's wildness. Wildness. You could only use the numbers from the pattern to make the item, because remember it's a little pattern they're doing. So it must be made with either one of these numbers: 2, 4, 8, 16, 32, 64, 128, 256. So if they gave me this amount of seashells in all, right, 384, and each they want to make 2 patterns, and they must be more than 100. Well, I could only use the 128 and the 256 pattern. So yeah, so I'll make one with 128 and I'll make one with 256. Party done. Rachel scored 340 points in a Scrabble contest. Jade scored 67 fewer points, more than Rachel, and 29 more than Sussy. How many points did Sussy score? Okay, so Rachel is here up top with 340. Jade is 64 fewer than Rachel, so let's just work out that one time. 4 from that is 6 when I borrow across here, and 6 from 33 is 27. So Jade is 276. Sussy. Sussy can't play games like what's that game where I used to say sus all the time? Good. That was real popular at the start of the pandemic. Sussy and 29 more than Sussy. So Sussy is 29 less than this. 276 minus 29 among us. 29, 6, boom, 7, 2 from 47. 247. Sussy's 247. How many points did Sussy score? How are they at 67? 67 is sus. 340 points in this Scrabble. 67 more. 67. Oh, I didn't read that good. Oh, my bad. It's 64 I put here. Oh, gosh. So 7. So there should be 3, I was saying. Oh, jeez. 3. So 7 from 10 is 3. Everything else would be the same. But this here was 273 minus, so much again now? 273 minus 29. So let's just double check everything. So Rachel scored 340. Rachel scored 340. Jade scored 67 fewer. And fewer points than Rachel, but 29 more than Sussy. So Sussy has 29 less than Rachel. So Sussy is 273 minus 29. So we should have a 4 there and a 4 there. So 244. 244 is good. How many of you all will hear from the start? Rachel placed third in the contest, and 4 students were between her and Jade. At what position did Jade place? So if Rachel is third, and then it have 4 people here, uno, dos, tres, cuatro. So then would be 4th, 5th, 6th, 7th, and then out pops Jade. Jade placed 8. Right, we have people here since the beginning, man. So 8. So Jade placed 8. You all good with that? Rachel placed third in the contest, and 4 students were between her and Jade. 1, 2, 3, 4 students. So 3rd, 4th, 5th, 6th, 7th would have been between, and Jade came in 8. Rachel wants her score to increase by 10% in the next contest. How many points does she obtain in her next Scrabble contest? If she wants it to go up by 10%, we just need to find 10% of Rachel's current scores. So 10% of Rachel's score. What was Rachel's score again? Anybody remember it off the bat? 10%. 10% is the same as 10 over 100. Rachel's score was 340. So 10% of 340 means divide by 10. So you get 34 points. How many points did she obtain? Oh, not 34. She should obtain 340 plus the 34. So she should obtain 374 points. 374 points. Let's go, let's go, let's go. On to number 39. We have any Justins out here? I feel like we must have a Justin in this chat. Justin bought the refrigerator shown below. 5,045. He made the first payment of 1,265. How much money does he still have to pay? That is easy. Let's give Justin a little subtracto here. Justin, thank you for paying your $1,265. Let's get that off of your bill. Doing our little subtraction skills here. 6 from that is, I am getting a good 8. And 2 from 9 is 7. Justin, it seems like you still have $3,780 for me. All right, Justin, let's see what else you have for us. Justin was charged 20% interest on the remaining money. Now, these kind of interest stuff and thing, you probably wouldn't see that show up. A couple of the questions that we did today, the topic itself wouldn't show up, but the logic and the mathematical understanding still helps, right? So 20% of 3,780, that's the interest on the remaining money. So this is 20 over 100, which is the same as, what is that? 1/5 of 3,780. So I can say 378 times 2 is a little simpler. 8 2s are 16. 2, right, that is 2 by 7. 4 plus 1. 2 by 7 is 14 plus 1, 15. Whew, like I'm running out of energy, right? 2 by 3 is that. So what is this? Is this 756? No, this 756. For those of you all who don't know, you'll just write it here because they want the new balance. So it means his new balance is the 3780 plus back the interest 756. So 6, 5 and 8 is 13, 15, 4, 5, 3, 6. Anybody has this? No one has this? 4, 536. Yes, they're catching up to me. Secondary entrance exam, SEA. Secondary entrance assessment. Okay. SEA. So 4536. Okay. We're going on because, as I said, this is an interest question. If you watch the framework, you would see certain things cross out. Justin paid the balance in 2 years. The amount paid in the first year was 2 times the amount paid in the second year. Calculate the amount of money Justin paid in the second year. So he paid one part in the first year. He paid twice as many as he paid in the second year. So this is the first year. This is the second year. How many parts do you think there are? In the first year, he paid twice the amount that he paid in the second year. How many parts there? Keep in mind, he has to pay back 5. How much he has to pay back in all? 4536. 4536. 4536 is what he has to pay in all. So there are 3 parts if you really study it. 1, 2, 3 parts. So we can find what one part is. So 3 parts would be all to pay back 4536. 1 part would be 4536 divided by 3. 3 could go into this 9, 3 could go into this 12. So you get 9, 12. Wrong. 3 could go into this 15. 3 could go into this 12. 1, 5, 1, 2. This was 6, right? Let me just double check and make sure that was 6. 6, yes. 1, 5, 1, 2. So 1, 5, 1, 2 is the answer. And my computer is jumping all over the place. Let's just pull it back down. Give yourself there, buddy. We're nearly done. 1, 5, 1, 2. And the reason we know that 1, 5, 1, 2 is the answer is because in the second year, it was 1 part. If they actually first year that, I would have had to multiply this by 2. All right. Okay. So those of y'all who are waiting for a topic to come back that you're going to get in the exam, here we go. We are back to stuff that you all can be tested on. A student has 80 beads of each color to use in a project. The bar graph below shows the number of beads that were not used. Well, yes, not used. I don't remember that. Were not used. Okay. 80 beads of each color to use in a project. So each one, if you bring it up to 80, you could kind of do a opposite vibe thing, and see how much of each get used. And if you all seen what I'm doing here, boy, because this go all the way up to 80. It means in yellow we use 70, understand? In yellow we use, before I even see the question, I've seen that. I use 70 in yellow. This is a really good bar graph question that you all can get. Which color bead was most used in the project? Not red, because we read the question properly. The question saying that this showing me how much were not used. So in yellow, we didn't use 10 beads, but 70 of them were used. So the color that was most used was yellow. Always in the smallest. That's the smallest here is actually the most used, because this is how much it was not used. How many beads were used altogether? Well, I can do 2 things. I can count up and subtract, or I can count up how many were used and subtract. But let's count up how many were not used. So 50, this is 30, this goes to 40, this one goes to 10, this one goes to 20. So adding up this real fast, am I getting 150 beads? Used, not used? Am I getting 150 beads not used? You all got that? So 20 and 10 is 30, plus 40 is 70, plus 30 is 150 beads not used. And in all we have 1, 2, 3, 4, 5. So we have 5 times 80 beads. So it should be 5 times 80 is 400 beads. No. there are lots of people who are benefiting from this. Don't, I think some of you always get pressed when you see the chat doing all kind of thing. That's okay if 1 or 2 people in the chat decide to talk about Attack on Titans and things. Don't get frightened. A lot of people in it. How many beads were used all together? So used all together, there were 400 beads in all, 150 beads not used. Used all together would be the 400 you started off with minus the 150 you didn't use, which gives me 250 beads were used all together. 250 beads is great. Ding, 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 ding. Down to the last question. Down to the last question. How many more blue beads? How many more blue beads than red beads were used? Easy man thing. Easy man thing. I see in 1, 2 boxes here. 10, 20. So you use 20 more blue than red. 20 beads. Just like that. Finish. So we learned a lot of stuff here. We even had time to check up, brush up on the Eats family and different things that would come into play in the exam. Don't forget to press like on the video. Next week Sunday we coming back again. I'm going to write a number here that you can WhatsApp to register for classes 1+1 86847242221. If you want to join my SEA class, well, my SEA class is filled, but we have other SEA class in the student hub. If you want to join a SEA class, you can free up if you want to join the Sunday revision session where we give the students these questions. The question that I'm going to do next week Monday, next week Sunday, we're giving you all it tomorrow in the Google Classroom, and you can do it and practice it like an exam and get it corrected. Any fighters is the name of the people who here from the beginning to the end. Any fighters today? So yes, this is the number to WhatsApp. Anything else? I'm planning to do a book. Hopefully you can get this done this year quickly, with all the formulae, all the common styles of questions, definitions, everything that I need in SEA Maths that you could checklist right before the exam. That an average student could read out this book in like 2 hours, 3 hours, and just checklist everything and just quickly just paint back over the wall and make sure everything is fresh in your mind. So like the ideal examination booklet. So stay tuned to my Instagram. You could go and follow me on Instagram or Facebook or wherever. You can let your parents know. So as soon as that is out, you'll see what bookstores it out in, and or you can be able to order it from the student hub. So this is my Instagram. I'm the same thing on TikTok, but I'm not as active on TikTok recently. Hopefully I get back. Shout out to all the fighters. Let me give the shout outs now. You might see a name pop up on the side there. Big up you and your whole team and your whole community and your whole village. Gavin, sorry, big up. Avery, all the people who revising properly. I see now the name popping up on the bottom there, right? Darius, Nathan, Megan, Void, Boom Bang Bing. W's all around. Wait now, this person was shut out. Instead of shout out, this person was shut out. Violence, the violence thing. Right. Lene, Diane. There's a couple more shout outs sneaking in here. Go and enjoy the rest of your Sunday. Maybe you could practice the topics that you find you was weak in. Until we meet again, people, love and blessings. If you didn't press like yet, listen, when I say this, some people they just like go in one eye and come out. Press like one time, that's how it's paid use. Close off the live chat. Press like before you bust out. This is me on Instagram, on TikTok. Feel free to follow. Love and blessings.